Hello pre-calculus students, this is Mr. McGowan, and this is a video, one of three, that we're going to be making. We want to work on dividing polynomials by other polynomials. This is in an effort to figure out which linear terms will be factors of an overall polynomial. So our goal in this video is to show you how to divide the third degree polynomial in numerator by the first degree or linear term in the denominator. So let's just do a few things first, and let's remember how to do division with just numbers. And a lot of you are, may struggle with doing long division because of what type of math you had maybe in earlier grades. But remember that the dividend is what you're actually dividing, the divisor is what is doing the dividing, and the quotient is the answer. So because we had even division here, we had no remainder. So the remainder was equal to 0. But if we did 24 divided by 5, we would multiply, let me just write this down, by 4 again, because 5 would not go in. We would take 20 and subtract 20 from 24, and we would have a remainder of 4. But this is not what you normally see on the calculator when you do 24 divided by 5. You see a decimal, because what you do is you take the remainder and you divide it by the divisor. So you have 4, and then you have and 4/5, because you take the remainder and you divide it by the divisor to give you 4.8. So we'll show you why that's important later. But that is something that we want to make particular note of, because when we do divisions with polynomials and we do long division, we want to write it out so that we have a complete answer. So when we work with long division, the first thing you should do is rewrite the polynomial to 3x cubed plus 5x squared plus 8x. Now there's no missing terms here, but if there was, like, let's say if that x term wasn't there, then you should really put 0x in its place as a placeholder. When we do the long division, I'm going to put the divisor out to the left, and I try to think, what do I multiply 3x by to get 3x cubed? And the answer to that would be x squared. So in doing long division, I'm going to multiply x squared by 3x plus 2, and I'm going to get 3x cubed, so my terms match, plus 2x squared. Now you have to remember that when we put that underneath, we're actually subtracting the whole quantity. So this will disappear. We have 0x cubed, but now we have 5x squared minus 2x squared, which will give us 3x squared. I bring down the 8x, and now I try to find a value that when I multiply 3x plus 2 by it, I match up with the leading term. So I'm going to put in plus just plain old x, and that will match me up with x squared, and then I do x by the 2, and I get plus 2x. Remember, it's subtraction, so that term disappears, and now I'm just left with 6x. Bring the 7 down, and now I'm going to, what do I multiply 3x by to get 6x? It'd be plus 2. So now I'd have 6x plus 4, and when I subtract that term, I get 3 left over. So I have a remainder of 3. But you should really write it as the following. So let me just zoom out a bit. And so what I have is, I had originally this expression. I'm going to just bring this over to here. Let me just copy that, and I'll paste it over here. So I have this expression that now I can write is equal to, that division was equal to the quotient, which is x squared plus x plus 2, but I can't forget about the remainder, plus the remainder of 3 all over the dividend, which was the linear term, 3x plus 2. So this is identically equal to this division. Hence, I have found the quotient and the remainder term. Well, it's not really a remainder term, it's a remainder over the dividend, so, or the divisor. So whenever you do long division with polynomials, you're always going to get, you notice we start off with a third degree polynomial when we divide by a linear polynomial, so we basically have like x cubed divided by x. We're always going to be left with a resulting quadratic, 1 degree less, and we may have a remainder, which, you know, you should put in proper form over what the dividend or divisor was, you know, the 3x plus 2. If we analyze this on Desmos, what we'll see is without that remainder, we haven't actually found anything that's equal. So what I'm going to do, So what I'm going to do is I'm going to put on Desmos. I'm just going to pause the video, but I'm going to put on Desmos the left side and see if that equals the right side. So I'll just pause the video, and then when I come back, you'll see me working on Desmos. Okay, so I'm back, and I've plotted the function that we were doing division by. So let's see if our quotient and our remainder term actually equal this. So going back to OneNote, I see I have x squared plus x plus 2. So if I plot x squared plus x plus 2, you can see that the two functions kind of look like each other in terms of long or end behavior if we zoom out, but we really don't see the same behavior until I add in the remainder term. And the remainder term was, if I go back, it was 3 over 3x plus 2. If I put in plus 3 divided by 3x plus 2, you can see that now the one function exists in exactly the same space as the other function. Hence, that remainder and the remainder and the dividend term or divisor term make up the difference to make sure that the two functions are equivalent. Hope this video helps, and the next video will show us how to do long division much quicker by using synthetic division and finding roots.